Okay, class, we're going to discuss fractions with zero, but before I do that, let me just remind you that we have this property of real numbers, and it says that any number multiplied with zero would equal zero, okay? So, for example, if I had 4 times 0, then this is repeated addition. This means that 0 would be added with itself 4 times. So that would be 0 plus 0 plus 0 plus 0. And then, of course, that's going to equal 0. Okay? Another thing that I want to say is that if I had a division problem, I've got 14 is divided by 2, that would equal 7. Okay? Now, every division problem can be rewritten as an equivalent multiplication problem. So this statement here could be rewritten as the denominator 2 times this 7, and then that would equal the numerator of 14. Okay? All right. So let's go ahead and begin now discussing fractions with 0. So if I had 0 divided by 5, and I wanted to know what this would equal, then I know that this mystery number that I'm looking for, I could take this division problem and rewrite it as a multiplication problem that would involve this mystery number. So that would be 5 times the mystery number would then have to equal the 0 on the top. Okay? But we know from the property of real numbers that we just stated at the beginning of this video that that mystery number would have to be 0. Okay? Any number times 0 would give me 0. Okay? So we see that going back to the top, 0 divided by 5, we figured out what this mystery number is. It is 0. Okay? And that is a real number. Okay, so 0 divided by 5 is 0, and that is real. Okay? So, using that, if I had 0 divided by negative 15, what would that equal? Right? We just now learned that that would equal 0. Okay? All right, let's look at another type of fraction involving 0. So let's look at a fraction where the numerator is non-zero. Let's say 4 divided by 0, and let's say that we wanted to figure out what that was equal to. Okay? So when we perform any mathematical operation, we want our answer to be a real number. Okay? So let's do what we did with the other problem. Let's see if we can rewrite this as an equivalent multiplication. So you would have to take the denominator and then multiply it with the mystery number. Okay? And that should then give us the 4 on top. Okay? But looking back at that property again, we know that if there is a real number that satisfies this, that real number, when multiplied with 0, would have to equal 0. It could not equal 4. It would contradict that property that we have there. So, there is no real number that satisfies this. Okay? So, we say that this mystery value, well, it doesn't exist. Okay? So, that mystery number is undefined. Okay? There is no number that would satisfy this division problem here. Okay? So 4 divided by 0 is undefined. Okay? So using that in another example, if I had 6 divided by 0, we would say that this is undefined. Okay? There is no number that satisfies that division. Okay? Okay, let's look at one more type. And the third type is where the numerator is 0 and the denominator is also 0. Okay, and so we're trying to figure out what value would satisfy this. Well, again, let's rewrite it. 0 times what number would give us the 0 on the top? Well, we see that 0 times 2 would equal 0, so we could certainly say that 2 would satisfy this multiplication. But we could also say that 0 times 8 would equal 0. Okay, so could we now allow this mystery number to be equal to 2 and 8? Is that going to pose a problem? Well, let's see. If we were to say that the mystery number is equal to 2, then we're now saying that 0 over 0 is 2, right? But we also said that the 8 would work. So that would then mean that we're saying that 0 over 0 is 8. Does that pose a problem? That we would allow it to equal multiple numbers? Yes, it does. So if I were to take the top statement, 0 over 0, and say that that's equal to 2, but down below we said that 0 over 0 is also equal to 8, okay? So 0 over 0 is equal to 2, but 0 over 0 is equal to 8. Well, now look what we're saying. We're saying that 8 is equal to 2, okay? And so what we've got here is a false statement here, okay? We ended up with a contradiction, okay? So what that means for us is that 0 over 0 is not going to be satisfied by one single number, okay? So 0 over 0 is indeterminate, okay? There is no one single number that'll make that fraction, that'll equal that fraction, okay? So, in conclusion, what did we look at first? We looked at fractions where the numerator was 0 and the denominator was non-zero, like a 7. Okay, and so that we said was equal to a real number, right? And that is 0. Okay, and then we looked at the second case where the fraction had a non-zero number in the top and was divided by 0. And we did not get a real number for this, okay? We said that this fraction was undefined, not satisfied by any real number. And then the third and last case was 0 over 0, which was not satisfied by any one single number, and then we said that that was indeterminate. Okay? So we can also just say that 0 over 0 isn't producing a single real number. Okay? All right, I hope that that helps.